It's a simple question. It's probably the biggest one we can ask. Are we alone? You look up at the night sky. On a good night, away from city lights, you see thousands of stars. Each one is a sun. Many of them we now know have planets, and that's just what we can see with our own eyes. Our galaxy, the Milky Way, has hundreds of billions of stars, and there are hundreds of billions of other galaxies out there. The numbers are silly, they don't feel real. Trillions and trillions of planets. So you look at all that, at the sheer scale of it all, and the question just hangs there. With all that room, with all those chances, could we really be the only ones thinking, wondering, and looking back? It feels impossible. It feels arrogant, even. To think that on this one little speck of rock, in an ordinary solar system, in an unexceptional corner of an average galaxy, something unique happened. Something that never happened anywhere else. That's one side of the argument from numbers. It's powerful. It's what most people lean on when they say there has to be life out there. The universe is just too big for there not to be. Let's break that down a bit. It's not just about the number of planets. It's about the ingredients, the stuff needed for life as we know it is everywhere. Carbon, hydrogen, oxygen, nitrogen. These are some of the most common elements in the universe. They're cooked up in stars and blown out into space when those stars die. They form clouds of gas and dust that eventually clump together to make new stars and new planets. So the raw materials are not rare. They're cosmic staples. Water, too. We used to think liquid water was special, but we're finding it, or evidence of it, all over our own solar system. On Mars. In the oceans hidden under the ice of Jupiter's moon Europa and Saturn's moon Enceladus. We see water ice on comets and in the rings of Saturn. It's common. And if it's common in our backyard, it's probably common everywhere. So you have planets. Billions of them. Trillions, probably. You have the right ingredients. Everywhere. And you have water. Also everywhere. It seems like you have a recipe for life that's being tried out on an unimaginable number of kitchen counters across the cosmos. It would be strange if only one of those attempts produced a cake. There's also the idea that we're not special. Scientists call this the Copernican principle. It started with Copernicus pointing out that the Earth wasn't the center of the universe. The sun was. Well, the center of our solar system anyway. Then we learned our sun is just one star among billions. Our galaxy is one among billions. The principle is that we don't hold a privileged position. We're not in a special place. So why would we be a special form of life? If life can happen here, it should be able to happen on other similar planets and other similar places. It suggests life should be common. And life, once it gets started, is tough. Really tough. On Earth, we find it in the most insane places. We find microbes in boiling hot springs. We find them deep in Antarctic ice. We find them in crushing pressure at the bottom of the ocean, clustered around volcanic vents that spew sulfur. We find them inside solid rock, miles underground. We find them in acid. Life, at least simple life, is stubborn. It finds a way. This suggests that the range of what we call a habitable planet might be much wider than we think. Maybe life doesn't need a perfect, gentle Earth. Maybe it can get a foothold in much harsher places. So you add all this up, the scale, the ingredients, the tenacity of life, the idea that we aren't special. And the conclusion feels obvious. The universe should be teeming with life. It should be humming with it. But then there's the other side of the coin. A famous physicist named Enrico Fermi was having lunch with his colleagues back in the 1950s. They were talking about all this, about the big numbers, the flying saucers people were reporting, the high probability of alien life. And in the middle of the conversation, Fermi just asked a simple question, a question that has haunted us ever since. Where is everybody? If the universe is so full of life, if there are civilizations out there that are thousands or millions of years older than we are, why haven't we seen any sign of them? No radio signals, no giant alien megastructures built around stars, no probes, no ships. Nothing. Just silence. This is the Fermi Paradox, the great contradiction. The argument from numbers says the sky should be full of civilizations. But the evidence says it's empty. Both things can't be right. So something is wrong with our thinking. But what? This is where things get really interesting and a little dark. People have come up with many possible solutions to the Fermi Paradox. They range from the simple and boring to the truly terrifying. One set of answers suggests there's a reason life, especially intelligent life, is much rarer than we think. This idea is called the Great Filter. The theory goes that for a civilization like ours to exist, it has to pass a series of hurdles, or filters. Maybe one of these filters is so incredibly difficult to get past that almost no one ever does. The question is, where's that filter? Is it behind us. Maybe the jump from non-living chemicals to the first simple cell is the filter. Maybe it's a 1 in a trillion fluke. We don't know how it happened here. We've tried to replicate it in labs and failed. We just know it did happen, at least once. If that's the great filter, then we're one of the first, or maybe even the only ones to pass it. Life itself could be incredibly rare. The universe might be full of planets with the right ingredients, but nothing ever sparks. That would explain the silence. It would make us lonely, but also incredibly lucky. Or maybe the filter is the jump from a simple cell to a complex one. That took over 1 billion years on Earth. 1 billion years of just single-celled organisms floating around. Maybe that step is the hard part. Or what about the jump to intelligence? Maybe having a big brain, the ability to use tools and build a civilization is not a common evolutionary outcome. Evolution doesn't have a goal. It's not trying to create smart creatures, it just favors what works for survival. Dinosaurs were incredibly successful for over 150 million years, and they did it with small brains. Maybe intelligence like ours is a weird, rare accident. So that's the optimistic view of the Great Filter. That the hardest part is behind us. We won the cosmic lottery. But what if the Great Filter is ahead of us? This is the scary one. This idea suggests that life gets to our stage of development pretty often. It becomes intelligent, it develops technology, and then it hits a wall. Something that almost every civilization fails to survive. What could that be? Take your pick. Technology itself is a good candidate. A civilization discovers nuclear power and blows itself up in a war. Or it develops advanced artificial intelligence that sees its creators as a threat or an obstacle. Or it burns through its planet's resources, changes the climate, and causes its own extinction. Look at us. We achieved all of those things in the last 100 years. We've been a technological civilization for a blink of an eye in cosmic time. And we're already staring all of those possibilities in the face. If this is the Great Filter, then the silence in the cosmos is a warning. It's the silence of a graveyard. It means that civilizations almost inevitably destroy themselves shortly after they become advanced enough to be heard. We might be next on the list. That's a heavy thought. The idea that the universe isn't silent because we're special, but because we're not dead yet. But there are other, less dramatic solutions to the paradox. Maybe space is just too big. The distances are hard to comprehend. Our nearest star, Proxima Centauri, is over 4 light years away. That means light, the fastest thing in the universe, takes 4 years to get there. Our fastest spacecraft would take tens of thousands of years to make the trip. Sending a signal is easier, but it still takes years. So a conversation with someone just 100 light years away would mean a 200-year wait for a reply. It's hard to build a galactic community like that. Civilizations might be out there, but they're like islands separated by impossibly vast oceans. We can't hear them, and they can't hear us. Maybe we just haven't been listening for long enough. We've only had radio telescopes for about 80 or 90 years. That's nothing. The universe is 13.8 billion years old. Our galaxy has been around for most of that. If a civilization sent a message 1,000 years ago, it might have passed us by before we had the technology to listen. We might just be tuning in at the wrong time. It's like turning on your walkie-talkie for 10 seconds in the middle of a forest and hearing nothing, concluding the forest is empty. Or maybe we're listening for the wrong thing. We assume aliens will use radio waves because that's what we use. But a civilization 1,000,000 years older than us might be using a technology we can't even imagine. They might be communicating with neutrinos or gravitational waves or something that we don't even have a name for. Their messages could be flying right through us right now and we're completely oblivious. It would be like an ant on the floor of a library trying to understand human communication. It sees people moving, maybe hears some rumbles, but it has no concept of the words and ideas being exchanged. We could be the ants. There's also the possibility that they are here, but we don't see them. This is the stuff of UFOs and science fiction. It's mostly dismissed by serious scientists because there's no good evidence. But some people think maybe they're observing us from afar, following some sort of prime directive not to interfere with a primitive culture. Or maybe they are so advanced they are non-biological, maybe they are vast planet-sized supercomputers or clouds of intelligent energy. How would we even recognize a being like that? We're looking for little green men in silver ships, but maybe we should be looking for a star that's dimming in a weird, unnatural way. And then there's the darkest idea of all. It's called the dark forest theory from a science fiction book, but based on some real game theory. Imagine a dark forest at night. It's full of hunters. Every hunter has to stay silent. Because if you make a sound, if you reveal your location, you don't know who else is out there. Is it a friend? Or is it something that will immediately see you as a threat and eliminate you just to be safe? The safest strategy in a dark forest is to stay hidden and listen, and if you do spot someone else, you destroy them before they can destroy you. In this scenario, the universe is the dark forest. It's full of civilizations, but they are all silent. They are hiding. They know that to announce your presence to the cosmos is a death sentence. The first law of cosmic survival is to be quiet. If this is true, the silence isn't because the universe is empty. It's because it's full and everyone is terrified, and we, a naive young species, have been shouting into the forest for 100 years with our radio and television broadcasts. We've been basically screaming, "Here we are, we're over here." It's a chilling thought. So how do we try to find an answer? For decades, the main method has been listening. It's called SETI, the Search for Extraterrestrial Intelligence. Scientists use huge radio telescopes, like giant ears pointed at the sky, and they listen. They scan different star systems, listening for a signal that isn't natural, something with a pattern, something ordered, something that could only be produced by a mind. So far, they've found nothing. Well, almost nothing. There was one famous incident in 1977 called the WOW signal. A telescope picked up a powerful narrow-band radio signal that lasted for 72 seconds. It looked exactly like what they were searching for. The astronomer who found it in the data printout was so excited he circled it and wrote, "Wow," next to it. But then it was gone. They pointed the telescope back to that same spot in the sky again and again. They never heard it again. It remains a mystery, a cosmic whisper that was never repeated. More recently, our technology has given us new ways to search. Instead of just listening for intelligent life, we can now look for any kind of life at all. The James Webb Space Telescope is a powerful new tool for this. When a distant planet passes in front of its star, the telescope can analyze the starlight that filters through the planet's atmosphere. By looking at the light, scientists can figure out what gases are in that atmosphere. And they're looking for something called biosignatures. These are gases that don't belong. So on Earth, our atmosphere has a lot of oxygen, but oxygen is a very reactive gas. Well, it doesn't like to stay free. It binds with other things. The reason our atmosphere is full of it is because plants and algae are constantly pumping it out. Photosynthesis. Without life, our oxygen would disappear. So if we find a distant planet with an atmosphere full of oxygen, and maybe some methane too, that would be a huge sign. It wouldn't be definitive proof of life, but it would be a smoking gun. It would tell us something is happening on that planet that shouldn't be. This is a different kind of search. It's quieter. It's not looking for spaceships or radio broadcasts. It's looking for the simple planetary scale breadth of biology. The discovery of a biosignature on another world would change everything, even if it's just alien algae. It would tell us the first great filter is behind us. Life is not a fluke. It happens elsewhere. And if it can happen twice, it can happen a million times. There's also a debate about whether we should just be listening. Some people think we should be actively trying to send messages. This is called METI, or Messaging Extraterrestrial Intelligence. We've done it a few times. In 1974, we sent a message from the Arecibo radio telescope towards a star cluster. It contained simple pictures of a human, our DNA, our solar system. It was a cosmic postcard. But a lot of scientists, including the late Stephen Hawking, thought this was a terrible idea. It goes back to that dark forest theory. We don't know who's out there. History on Earth has shown us that when a more advanced civilization meets a less advanced one, it usually doesn't go well for the less advanced one. Why would we assume it would be different with aliens? Hawking warned that an advanced civilization might see us as a primitive resource to be conquered and exploited. Shouting into the cosmos before we know what's out there is a risk we shouldn't take, he argued. The debate goes on. Should we hide? Or should we take the chance and say hello? Let's imagine for a moment that we find something. Not a vague signal, but a clear, undeniable message. Or the Webb telescope finds a planet with a textbook biosignature. What happens then? The world would change forever. It would be the single greatest discovery in human history. Our perspective would shift instantly. The Earth would suddenly feel very small. All our human squabbles, our wars, our national borders, our religious differences, they would all seem so petty and insignificant in the face of this new reality. We would no longer be humanity. We would be Earthlings. Maybe, just maybe, it would be the one thing that could finally unite us as a species. The religions would have to grapple with it. Many would adapt, finding ways to incorporate the idea of alien life into their beliefs. Some might crumble. Science would be energized beyond belief. We would have a new data point. It's life. We would no longer be studying the one and only example we have. We could start to understand the universal rules of biology, not just the local rules of earthly biology. and we would be faced with a new set of questions. If it's a message, can we decode it? Should we reply? What do we say? Who gets to speak for Earth? If it's just a biosignature on a faraway planet, can we learn more? Can we send a probe? It would spark a new age of exploration, a new drive to reach the stars that we haven't seen in decades. Of course, there would be fear, panic even. People would worry about an invasion. They would worry about alien diseases. Governments would worry about losing control. The unknown is always scary. But it would also be a moment of profound wonder. And this brings us back to the beginning. Back to you looking up at the sky. The truth is, we don't have an answer. We have two sets of good arguments. One says the universe must be full of life. The other says, if so, where is it? We have a lot of theories, but no data. We are working from a sample size of one us. Maybe the answer is just that we are the first. Someone has to be. In a universe that is 13.8 billion years old, but will go on for trillions more, maybe we're just early to the party. We're the first ones to turn on the lights and find ourselves in a vast, quiet, empty room waiting for others to show up. Or maybe there were our Earth ideas right. Maybe the long list of things that had to go just right for us to be here is what makes us unique. We needed a star of the right size and stability. We needed to be the right distance from it. We needed a big planet like Jupiter out there to act as a cosmic bouncer, sucking in or deflecting asteroids. We needed a large moon to stabilize our tilt and create tides. We needed plate tectonics to regulate our climate and recycle carbon. We need just the right amount of water. Maybe the list is so long and the odds of getting every single item correct are so low that we are the only ones who made it. This would be a lonely conclusion, but it would also give us a profound responsibility. If we are the only consciousness in this entire galaxy, maybe even the entire universe, then we are the universe's way of knowing itself. The thoughts we have, the art we create, the love we feel, the questions we ask these things might be the most precious things in existence. If we let them die out, if we destroy ourselves, we might be extinguishing the only light in an endless darkness. That's a heavy burden. In the end, the search for extraterrestrial life is as much about them as it is about us. It forces us to confront our own existence. What does it mean to be alive? What does it mean to be intelligent? What is our future? Are we capable of surviving our own technological adolescence? We haven't found them, and they haven't found us. So, for now, we are alone. We are on this single, beautiful, fragile planet all together. And we have the stars to look at. We have the mystery, and we have the question. The question itself is important. It drives us. It makes us curious. It pushes us to explore, to learn, and to look up. And maybe in the long run, that's the whole point. The search, the wondering, the shared sense of awe at the vast, silent cosmos. We don't know if we're alone, but in asking the question, we find each other.